So as the last people flood in, I'm going to start by introducing myself. Hi, I'm Ralph. I'm with Unity. I lead the scripting team, and I'm one of the people working on WebGL. The scripting team traditionally works on our VM, the scripting languages and API implementations at Unity, does some work on the code editors in Unity. And in that context, it's maybe a little bit strange that I'm standing here. But there's multiple reasons that the scripting team is heavily involved in WebGL, and I have a very deep personal interest into it. So I get to talk a little bit about it today. To kind of give you an overview, I'm not only going to talk about WebGL, I'm going to start off a little bit what Unity on the web means today. To give you context to where we're going with WebGL, we announced WebGL at GDC this year. What I'm about to show you today is already a long way ahead of what we had back then. We are going to, as Lucas mentioned this morning, I guess you were all at the keynote, right? Was everybody at the keynote? Was there somebody not at the keynote? Good. One person, okay. You missed a lot. What we announced is that currently 5 is in private beta or in closed beta. Unity WebGL is part of that. We announced at GDC that Unity would be part of 5. We're going to do that as an early access for your WebGL, which means that we're going to be shipping it with 5.0 and improving over the life cycle of 5. Has a few reasons. One thing that I want to have enough time reserved for is Q&A, and I'll kind of allude to more, but I want to have some time to have a little bit of a discussion with you guys about what this will look like and how you can use it. Hopefully, after my presentations, there are some questions which I can answer, but also I would like to ask you some questions on usages of the technology I'm about to show you. Now, again, that's the future. That's the shorter future or the short-term future. Today, however, we're talking about, if you were talking about Unity on the web, we're talking about the Unity web player primarily. This is by far the best gaming experience on the web. If you talk about deep gaming experience, you know, interactivity and all the features you need for rich gaming online, the web player offers that today. That number, the 350 million installs that we have, that is a statistic that I had during GDC. And back then we thought it was old. I'm pretty sure it is very, very old and that we are far beyond 350 million today. However, I'm not going to state numbers that I don't know for certain, so it's at least in that region and higher. We're seeing that number grow, at least. It's something the web player is actually becoming more and more popular, as it's such a nice way to deploy games to the web. And to some of our collaborations and partnerships, this actually became something that the general public get much more access to. To give you an idea of what that really means is that if you go to a gaming portal, like a bigger gaming portal, like in this case, as an example, Kongregate. Their director of developer relations, David Chu, said this in one of his presentations. 93% of their users already have the Unity web player installed. So that is actually an amazing statistic. If you're targeting larger gaming portals today, you will have 93% of their users being able to get it, and otherwise that remainder needs to get the installer and download the plugin. Now, outside of Kongregates, of course, there are a lot more gaming networks. I took this because I had such a nice quote. We can kind of say that for those hardcore gaming, or maybe not that hardcore, but for gaming portals where people direct themselves to start playing your games, you know, that these numbers are very valid. People are very willing to install a web player. Now, if I kind of show you what's possible today, and I'll kind of mute the sound a little bit. These are 3 of the top games on Kongregate today. These use almost desktop-like feature sets in the web player. So they'll go full screen, they immerse the user, they use networking like this game, Cities of Steam. They'll have very rich graphics because through the plugin we can basically just access the graphics card like a normal standalone player. It's a very rich experience through content streaming and networking. This is an FPS. You know, this is just a multiplayer shooter online. This is very, very popular. I'll be honest, as a developer at Unity, I don't always get time to play games on my desktop computer. I do have a Vita and an Xbox for when I'm really away from work. But I started playing that, and I played that for a little bit too long. So we captured those 3 examples, and they kind of show what you can bring to the web as almost desktop gaming experiences in the web player today. But an important note there is that the web player strongly integrates with also its surrounding, the browser. So on Congregate, there's chat features. There'll be stats that actually show up next to you. You can invite people to games. So there's actually an augmentation because of the player being in the browser. Now, I've been speaking about one portal so far, but another thing is kind of like if we look at what we did last year in one of our announcements, we kind of announced this relationship with Facebook. I don't know what that definition means, but that was at least the title. What we did together, and this is the part I do understand, is that we kind of started integrating some of the Facebook features to an SDK. Together with Facebook, we worked on an SDK that allows you as a game developer to easily integrate their features. So that means, friend requests or kind of, setting your own status on playing this game or, well, a few things. And this is both for the web player, but also for your mobile devices. So that's a very kind of like across the board experience where you can play a game in the web player. And if you build the game for both web and mobile, your game can be played on both devices. And a very important thing here is that when we talked about gaming portals being the access point and having that 93% of users already having it on a site like Congregate, then on Facebook now you're looking at a much broader audience. An audience that might not necessarily want to jump through hurdles to install something to be able to play something. Or, I guess if I take my sister as an example, she's not the first person to be very likely to click on an executable and say, yeah, put this on my computer because a friend sent me something. So one thing that Facebook did really, really well is also help you as a developer in integrating with them, is streamlining away of that install, taking away that fear of installing something. It will very clearly in picture tell this is going to happen now. You're going to have to click on this and it will ask you for this and it will make it look very friendly. And, Facebook, I guess, generally will be trusted in kind of offering that in their style, allow people to go through the steps of installing the web player. Now, that leads to more conversion. And I think that if we talk about the web player, this is a really big question we get back from people is, how many people have this? How many people do you get as far as to installing this? A very nice example of that is that NASA, when they were landing that opportunity, that was followable in real time through the Unity web player. People around the world could follow that and would get all the telemetry sent through Unity, have a look at what was happening with opportunity. And they also had to really make sure that people would trust them to install that web player that we have and make sure they can follow it. And these people are very willing. You come there with a purpose. You want to do that. So that is actually, to a large amount, the web player is more and more there, so that kind of gets a network effect. People will tell each other about the games they've been playing in the web player, but people will trust it because they also want to play the game. But it is also one of the downside, of course, of our web player. Gives you all these features, gives you a really great, rich environment, but there is a cost. You need to have that plugin. 350 million or more, so it is a bit of a problem or a thing that changes. And there's one thing we can see in the web player is that it is huge in Asia. Today, 42% of all web player users are in Asia. So there's a big difference, or a big balance point compared to here more in Europe and Northern America, or the Americas. And Asia is still seeing heavy growth. So they're kind of like getting more and more on board with the web player. And one of the things that we do is we have a partnership with Qihoo that ships the 360 browser, and we're actually in their browser with the web player. So people already have it. So that is some explanation to that growth. Now, that is today. That is the web player. That is some of the scope of what our web player is today. And I'm hoping that you're all kind of here also for the shiny new stuff. Okay, so I'm going to go dive in that a little bit and also talk about what we're doing there. And I'm really personally very excited that we're able to talk about this. We've been working on this for a very long time, and I'll explain to you how we came from not having this to having this through a very organic process, I will say. But before I start explaining something about WebGL, I have to kind of disclose something about that name. And that is, we use this as a cover name for a set of technologies that you will need to deploy to the web using WebGL, or which utilizes WebGL. So the cover name is basically for a technology stack that includes HTML5 features. So this is web audio. This is full screen mouse locking. The sets that are currently available as part of the HTML5 technology stack. Then there's JavaScript, which we use instead of, you know, assembly code on a device or on a CPU running things. And on top of that, there's WebGL. And I kind of, you know, we use this name, but just keep in mind that that is an entire technology stack that we're talking about as we go through this. And an important other thing is that it requires WebGL-ready browsers. WebGL is been around for some time right now, but not all browsers have it on by default on your machines today. So it's still something that is up and coming, but we can see that it's going very rapidly. And while that, I'll go in a little bit more into the details of what that means for you targeting machines or targeting browsers. It is important to know that when we did this 2 years ago, it was kind of like experimental browsers. One browser would be doing better than the other, and things were still very much in flux in terms of implementing things. But during that period, we already started looking at this and started looking at how we could do things. And that comes from also us looking at the evolution of gaming online. I mean, when Unity was kind of first around, the web deployment option was actually one of the bigger things, you know, and as MOBAs took over more and more and more, you know, we now internally see that that gets much more used than our web player. Our web player is still hugely important, but it's kind of been balancing back and forth. And one of the things we're now looking at, you know, seeing this motion like David was talking about this morning, you know, people bringing their skill set back from mobile to the desktop, bringing them back to online. You know, that we also kind of wanted to be ahead of the curve again. And this is 2 years ago, or 2.5 years ago I'm talking about. And you know, the motion we started seeing was the plugin-less web. People talking about, you know, we don't like plugins in our browsers, or hey, we're going to have a set of technologies that allows you to do this without a plugin. And that's kind of the term that I use. I'm not sure if there's a better technical term with it, but the plugin-less web, the open web in which all this technology can be run without a plugin in your browser, that's kind of the technical evolution to let us want and do this. Now, ultimately, I do believe that this is better for the web as a whole. Like, not having plugins is actually a good thing. And one of the important things is, of course, that friction of installation that we were talking about before is, you know, there is no more threshold to install something. There is no more guiding your users to do your content by having to install something. There's just a browser that has this built in. And another important factor there is, for example, security. If you look at browser vendors and what they say about plugins, a lot of their concerns are in security. In the current plugin models, it's possible to scope something in a way that you basically can exploit somebody's computer through a plugin, and that's a problem. And that's something which is very real every day on the web. I guess you all get plugin updating, and I won't name any names, but there are a few that say something to you every day. So this is kind of where we want to go together with the web, and also why we're very big proponents of what I'm talking about today. So Unity wants to be there on the web. And one of the changes that we're making in Unity 5.0, the web player remains to be there to the 5.0 cycle. It's not going away. We're going to have that there. We believe that it's still valid today, that it still has capabilities that can't be reached through any other way, so it's going to be there. Well, what we are doing is, well, we actually announced this during the 4 cycle already. We're not going to do any Flash anymore. It's completely gone in 5.0. We're not going to do any NACL anymore. It's completely gone in 4.6 already. So we're really focusing all our efforts towards these two things, the web player and WebGL. To come to those conclusions, we have spent a lot of time researching and developing different directions. We've played around a lot. And to kind of make sure that Unity is the best tool to deploy to WebGL, and I really believe that today we're already in that state. We kind of have to go back to the history and kind of show, I will want to show our process of getting to here and kind of explain what happened for me to be here so happy about announcing this. And that 2.5 years ago, one of the starting points was a hack week. And this is a concept that you might or might not know from our blogs, but they used to be called ninja camps at some point. What it basically means, all the devs from Unity kind of get together for a week in an office that then turns out to be kind of small, you know, side-by-side programming like this, but a lot of fun. And we work together on projects that we pick ourselves, kind of as, I want to try this or I want to improve this. And a lot of the innovations that you've seen in Unity, even today with, for example, some of the new lighting stuff has first been iterated and tried out over these hack weeks. It's kind of like, this is a time we can take, where we have a full week where we can play around and see what we can achieve. So one of my personal things with this is that one of my markings on the board was like, let's try and do WebGL. Let's just see what it can do today. So we started kind of researching this, and because we already had Flash, we already had some of the pipeline in place to do it, although we knew that we didn't want to take all of that. But we had an LLVM backend. An LLVM is a compiler tool chain. You know, if you compile to iOS, actually you're using LLVM inside there. And we had that, we kind of transformed that to JavaScript. And in this first hack week, we had to modify that backend so that it would export JavaScript from C++, just to be able to take our engine code and convert it back and run it in the browser. And after a week, we do a presentation at the end of such a week. We have a big projector, all the devs lie around in beanbags, and we kind of all look at the screen, and every team gets to do a presentation. And while everybody was in beanbags, the WebGL team, which was quite a few people, was actually all still behind their computers because we had the engine running. We could see like log messages and seeing it trying to render, and you know, we had like pics attached to see what was going wrong because we knew it was running, but it wasn't rendering. And we just didn't know what was going on. Now, funny story, it turned out that we had alpha set and you couldn't see it rendering, but that's another. So this was our first week, and we kind of like took that work as, okay, what we could see is that it was running at around, well, I mean, 14 times to 15 times slower than our web player. So as a proof of concept and understanding where we were going, this was very clearly, wow, this is way too slow. Now, in that period, the period leading up to actually this picture, which is one of those hack weeks, what we did was, or what happened was that we kind of talked to browser vendors about the future of the web, and Mozilla, notably Martin Best, who's here today with us, reached out to us and said, hey, we have this idea of doing this thing in JavaScript and you're not doing a plugin. And we're like, yeah, well, kind of no, but okay, let's try it. And they really sent out their top guys. They sent out 5 of their top guys to work with us in this next hack week. So we went kind of back and we kind of did the same thing all over again. We wanted to first get the engine up and running. No scripting, no nothing, just engine running, and make sure that we see it start up and spin a cube. And the proof of concept that anything, any new platform that we kind of try out at Unity is a spinning cube, because it means that the engine is running, the shaders are being translated correctly, all the text in the frame loop is working correctly. And it is really just the simplest thing we can do to make sure that we know the engine is working. Now, this is a video. It's kind of shot on a potato, but it's going to be the best footage that we have left of that hack week. This was the engine starting up in the browser. So we actually put that picture in to kind of at least keep people kind of entertained, because it took a while. And yes, we had the engine up and running, we had a spinning cube. Now the nice thing is as soon as we have the engine up and running, we can immediately do a lot more, of course, because we're bringing the entire Unity engine. So this was that first week, the result. This is a game by Mad Fingers, and this is a fly through to one of their scenes. And as you can see, you know, the engine was rendering, things were being animated and skinned, and the camera was animating, and this scene already worked. And I think at Unity were already a lot of people, wow, this actually works. And it wasn't, you know, fluent yet, it wasn't totally there yet, but we can see that the engine can work. The nice thing about that demo, specifically for us at that point in time, was that it doesn't involve scripting. There's just animation curves. There's just the camera moving over a spline, and there's really, for the rest, nothing that involves real scripting. So we didn't have to worry about that. And I'm going to dive in further than that, but one of the successes we had during this week was also, okay, we have this bad startup time, we know it's really not fast enough yet, we need to think about how to implement scripting ourselves, but the browser still needs to improve. And this is actually one of the, well, through our discussions with Mozilla that started there, this is one of the innovations that brought us here today. This is mscripten, and when I talk about an LLVM backend that we had ourselves, we actually dumped that and went over to mscripten, which is an open source project that is a cross-compiler for C and C++ to JavaScript. So they kind of were working on this already, and we were at the beginning, we were like, we'll use our own. But what is nice about mscripten, this is done by the people who also are so close to the metal in JavaScript. So we don't have to figure out how JavaScript works or how the newest optimization in JavaScript works. They were doing this, so we picked that instead of doing this ourselves. And more importantly, at a later point in time, mscripten could target something called asm.js. Now, I'll leave you to read that quote yourself, but that 1.5 times slower than native might look like a bad statistic. But if you think about us running it the first time and at least knowing that it was 15 times slower, then this is an order of magnitude faster. And this 1.5 is actually a great number for something that runs protected in a web browser where we don't have to worry about anything. And we can still see that, that number in an earlier presentation that I gave about this was 2.0. So we can still see forward motion and momentum in getting this number faster and faster. And it's actually pretty insane that JavaScript can perform this fast. Like Lucas said this morning, it was the language that changed the color of the button, and it does this now. So asm.js is a very smart solution. We really believe in it. It's the smart thing about it is that it's a subset of JavaScript. So that means that it's actually just normal, valid JavaScript, but it's optimizable by browsers that optimize for it to run much faster. But if a browser doesn't support asm.js, the content will still run, just slower. And by having content online that runs through asm.js, and by having more and more content online, every browser will have to start optimizing for it too. So it's a very, very smart thing to do. And while we're talking about smart people, I'm going to kind of talk about the people who did this with us, Mozilla. So they kind of reached out to us at the GDC. We started doing these hack weeks, and I want to give you one kind of funny note. Is like they were making the statement that it was possible when we already had that 15 times. We were not so sure, and Martin was talking to us, and me and Lucas, and he said, well, I think it might be possible. And we said, okay, fine, come over and prove it to us. And I'm going to let Martin speak right now if you want to join me. So this is Martin Best from Mozilla. The other person on the picture is Vlad, and he's the inventor of JavaScript, or WebGL. Yeah. And it's important to note that the mscripten inventor, the asm.js inventor, and actually the inventor of JavaScript at that point in time were all at Mozilla too. So I'll leave it to you, Martin.
Thanks. So when we first started thinking about this project and how we would do this, I'm going to just share a few notes from being on the other end of that table and having Unity look at us like we were crazy. We were basically proposing the idea that we could take a language that was designed running 15 times slower in our demos and would take 5 minutes to load up, that we could get this to run at near native speeds somehow, and that, yeah, it worked on paper, so believe us, right? So we took a long time to sit down and look at this. And through collaboration and through working closely with industry, especially Unity, we were able to put our engineers into a pressure cooker that said, this is the bar, period. And this is what their users expect. This is what the developers expect. We need to do something. And through those collaborations, through attempting to do this, two technologies emerged which were particularly exciting. So one is the IL2CPP technology, which will benefit a lot of platforms on Unity and is something that they're developing pretty heavily. And then asm.js. And asm.js, as Ralph explained, is totally legitimate JavaScript. It follows the standard perfectly. But it also has an extra layer of rules that if you optimize for those extra rules, you can then get it to run at near native speeds. And as I said, in Firefox right now, we've got it down to 1.5 of native speed. So that's already starting to enable an awful lot of power. This is having repercussions we did not expect in encryption on the web, in people writing video codecs using WebGL and asm now, circumventing web standards to produce their own web codec. So started with games, but it's starting to explode quite a bit outside of that range. So to give you some idea of how it went, as Ralph said, when we first started, it was about 10 to 15 times slower, depending on which browser you were doing. We had these very long load times. Now we can load up 1 million lines of code in under a second. We can get, in Firefox, you got 1.5x of native. Chrome is currently down to 2.3x of native. And the new version, new engine in Safari, which is the FTL engine, is now coming in between those numbers. So we're seeing a lot of movement in terms of people optimizing, some taking different approaches, but all optimizing that, getting it faster and faster and faster. And the race is really on. We used to have a huge lead. Now it's getting a little bit smaller, so we've got our work cut out for us. These collaborations are not done. The web is now ship-worthy, so we're seeing people do that. We're seeing about a new product come out a week, and that's saying a lot, considering that Unity has yet to ship. So we're really excited to see what happens when that comes out. But we're working on partnerships. Some of this, I think you'll elaborate on later. But SIMD is something we're looking at to improve skinning code. Threads with shared memory is something we're actually spending a lot of time thinking about, because this is something we really need to unlock the power of devices. But we need to make sure we do this in a way that is safe for the web, because but we think we have a solution now. WebGL 2, which is OpenGL ES 3.0, is currently in the works. VR technologies, API performance, we're going to be pushing closer and closer to native speed, so there's still a lot of headroom there. So even at 2.5, we're not done yet. This is just how far we've gotten in the time frame we've had. So we already have a roadmap that should get us much closer to native. And finally, we're going to start optimizing for mobile in earnest. So that's sort of the next evolution of this. So right now, really solid on desktop, and now we're really starting to focus in on things that will help native. So I'll leave you with a few points. One is that working with Unity has been an absolute pleasure. I can't say it enough. These guys pushed really, really hard to make this happen under really tough circumstances. I can say most other companies would have shied away from this hard of a technical challenge, but they really gave us a lot of their time and effort to make this happen, and it's having a massive impact on what can be done on the web. We're also extremely grateful that they've decided to give it away for free to both the community as well as to the on the pro version. This is really exciting and really in the spirit of how the web is, so we're really excited about that. Unity 5 shipping, we feel, will be a big milestone in helping this technology spread. So we as Mozilla want to help early people who are attempting to use this technology. So after the talk, if you are interested in targeting this technology, please feel free to come and talk to me about it, because we are interested to hear what people's intentions are and see if there's ways we can help connect you with our users. So that's it. Thanks.
Thank you.
Thanks so much.
Oh. Thanks so much, Martin. It's really important to note that without those two bigger innovations and the path we're on now together, none of this would have been possible. And I think it's really important to note that the effort that Mozilla has been pushing into us, pushing with us to get this to work, it's been huge, and we're really grateful for that. So thanks. So now the important bits for you. You want to ship your game on WebGL. So we're going to go a little bit back from all the history and go to current day. And it's important to note that if you take WebGL as we have it today, it's not on par with WebPlayer just yet. So Martin mentioned threads, mentioned SIMD. These are important features that we use for performance. The asm.js brings us very close to native, but it's not as fast just yet. So you're going to have less performance in some cases, but it depends on what that is. And it's still early, so the early access in 5.0 is something that will allow you to publish without plugin, but we do expect that we're going to have a lot of feedback cycles together with you to get things right and make sure that we do the right things. So the important thing to notice is how this works. It's very simple. It's under the build button. So you switch your deployment target and you hit build and it starts building your project. That takes a little bit longer today. As you will see later, there's a lot more involved to do it, but you can still work in the editor like you do before, hit build, wait for a little bit and get content out. And then the important part there is, of course, that like any platform, your content needs to be ready to run on this one. Like for example, desktop has a pointer device and most mobiles have a touch device or touch input. And for WebGL in a browser, there are similar things that you need to think about before you can actually deploy existing content, but it's very little. What we're going to aim for in the first release, and Martin kind of alluded towards this, is that we're aiming for desktop browsers today. We're aiming for desktop Firefox. We're aiming for desktop Chrome as Safari comes out with their new JavaScript engine and WebGL enabled by default, as they announced at their keynote this year. We're going to enable them, and we're already kind of like looking at if that all works. It's important that we say that it's desktop today. That asm.js innovation hasn't hit everywhere yet, so also as everybody's optimizing on mobiles right now, we're not seeing the best performance. We're giving you a warning when you try and run content on a mobile device that has WebGL enabled. We're not actively blocking you away from it, but the experience is just not good enough for us to say, let's go for there. So as that evolves, we keep on looking at it. We keep on working on that too. Right now, desktop is our goal. It's important to note that with that build button, of course, you're constrained by the browser capabilities. So you can't access file from a browser. So what you can do in a standalone player, what you already couldn't do in the web player, you also can't do in WebGL. You can't go to the file system and just take a file from the user without them explicitly allowing it or saving something on the hard drive and running it, for example. So there's very simple constraints you need to keep in mind in that sense. And before I start telling you that there are constraints, I also want to really make sure that, that you know that there's actually, everything is there. Every subsystem is there. So there's physics. The new GUI system that you saw that morning works. You know, we can deploy that to WebGL and it just works. We have 2D and 2D physics. I'll have some demos later. Nav mesh, recast, Umbra collision calling or occlusion calling. The new audio system, you know, all those mixers, everything works. Although it's important to note that we cannot support fmod without threads. Like if we try and do processing audio needs to be in time, otherwise it starts stuttering. So until there's threads in browsers, we cannot do that. So we support as much as we can, but audio effects are a little bit harder. We support some of them. And basically everything that we can support, we will support as long as it's performant enough and it guarantees you a good build quality. So again, it's just the build button. Now, the cross-compilation of the player we talked a little about, we take C and C++ through Mscript and it becomes JavaScript. And now you have to kind of allow me, and I hope you will, to nerd out a little bit. Because I'm going to talk about something that we have a talk later today. John, are you still here? There, John is waving. He's going to be doing a talk after this one here about something we called IL2CPP, one of the innovations that Martin named. And this is actually why the scripting team is also very deeply involved in this. IL2CPP is really cool technology, and I'm going to really nerd out together with you on this. It is a cross-platform AOT compiler for .NET bytecode that cross-compiles to C++. We're all here still? Great. So we went over all the options to take your scripts, your C# scripts and your Unity scripts and see how we could get those to run on the web. We had that demo that animated but never had any scripts, but now we needed to fix the other problem, which is we don't want you to have to rewrite your scripts in JavaScript and then run them on the web. You should be able to take your existing content, take existing items on the asset store and run them like anywhere else. Of course, we cannot run mono in this, and that has very different, or very many reasons. And one of the things is there is no JavaScript backend for mono. We actually did look at doing that as an option. We also looked at solutions similar to JSIL, which converts C# to to normal JavaScript in their model. But we chose to go this direction. And IL2CPP is much more as an innovation than it is just WebGL. But it's one of the bigger use cases. To explain to you how that works, and this is going to be very simple. We take your C# and your unit script in your project. We take all the assemblies that you bought from the asset store. We push them to the mono compiler. Over all the scripts we push to the mono compiler. We get out an assembly. We patch that assembly. We get out a new assembly. We strip the assembly, take away all the code that we don't need and we know that the engine is not using or you are not using. Get another assembly, push it through IL2CPP. We get C++ code from that. At that point, it enters Mscripten. We turn Mscripten internally turns this into LLVM bitcode. That is then pushed into the LLC part of the LLVM pipeline, which then outputs JavaScript. Mscripten then takes that JavaScript, pushes it to Node.js with running a Node.js optimizer, and out comes new JavaScript. That's quite simple, right? Now, the real insanity here is that when you look at this, and my favorite tweet I saw as a response to our WebGL announcements was, Unity announces running C# on the web through 20 compilation steps and nobody bats an eye. So it is 2013, but the surprising thing is this performs great. This is not just a little bit good, this really performs great. And to kind of explain to you how it works and finish that up and then start talking numbers and demos, I'm going to take 3 of those stages that we have. I'm not going to show you all the steps, it's boring, and you really want to go and see John's talk that has a very interesting slide deck on how this exactly works. If I do this, then I'm going to keep it simple. So this is one of the scripts that is in dead trigger 2. This is reflections. It iterates over an array and checks if the system actually supports render texture. So it's basically a setup in a mono behavior, the start. We take this becomes IL. I'm going to skip that step, but then we get IL2CPP to run this, and this is what comes out of IL2CPP. So again, John is going to be much more eloquent in explaining this. I'm just going to cut this very short, but this is what comes out when we turn this into C++. So it's kind of a representation of the IL. Now we give this C++ to Mscripten, and this comes out after we pass it through Mscripten, which is JavaScript. Although you could argue that not everyone can humanly read this anymore, it is valid JavaScript. And this is already that asm.js subset. The one thing that I kind of didn't do for clarity is that final step where the code is one more time ran through Node.js, and being optimized away, then it takes away all the white spaces, it takes away all the names for all the functions and variable names, and makes them very, very tiny, and basically you have this giant block of text which nobody can humanly read. This is the humanly readable version, this is the development output. Don't worry about this. It's very important. I'm just telling you this because I'm geeking out. Do not worry about this. One of the experiments we're currently doing is you debugging your code, which is kind of complicated given that you don't want to be debugging this in your browser. We can't really add the mono debugger or attach mono develop to it right now, just because we can't do it from a browser perspective, although we are adding this to IL to CPP. What we're trying to use is a feature called source maps, so that you can actually see what C# this is in your browser as the development console opens. I'm not making any guarantees when that lands, but it's like you can see C# in the browser. We need to do some work with all the browser vendors to make it actually work, but it's pretty insane. So John is going to help me out, because I can't play and talk, obviously. This is one of those, oh, it didn't open? Uh-oh.
Here, I'll click over there.
Can you click over there?
Yeah.
Oh, you need to move the browser. So one of our internal benchmarks, so one more technical thing to fix. We have some time, it's okay. Gamma control. Can we dim the lights otherwise? Is there anyone here that is actually controlling lights and that kind of stuff? Anyone in the back? I see something. Great, thanks. So it's a bit dark on the projector. I didn't really think about that. But this is Stealth. Maybe you know it. It's done by our Learn team. It's an example project. Or could you dim the lights entirely? Otherwise, everybody's looking at a dark blob, which I didn't really account for. But it's one of our Learn team demo projects. They'll kind of teach you how to build this. And we know this project as Unity. We know how this should work and what it should do. So we kind of took this as a demo that John. As a demo that we both know how to run, and we know when something is broken, what might be broken. So we took this as, okay, let's work on IL to CPP, mscript, and asm.js. Make sure that this demo works, because if something's broken, we know what's on it. So this works. This is purely C# though. Maybe we should open a little bit of a brighter demo, the other one. Yeah, I think that's quit. So let's look at something else. This is something, I'm pretty sure you all know this project, and honestly it's not something that is per se the showcase, but oh, should I open that up? Oh, there we go. So as you can see, running in a browser, Angrybots, you all know this project. Okay, can we put the volume a little bit down? I think it's broken, but we'll iron that out. So what this project is for us as a scripting team is that this is almost entirely Unity script. And when we started on IL to CPP for WebGL, we kind of decided, yeah, we want to have everything to work, but we're going to focus on C# first, and we'll figure out Unity script later. And as it turned out, as we were working on IL to CPP and basically enable all C# and normal .NET features, we could almost just support Unity script out of the box without putting a lot of effort in. So aside from that little audio bug there, that kind of concludes the part of scripting in this sense. It's something that now works. We can take our own stuff and it runs. There is a little bit of more do's and don'ts that I want to touch upon. So when we talked, or when Martin was speaking about SIMD, our skinning code heavily relies on SIMD and threading. Two features currently not available in browsers. So as Martin alluded to, threading is underway, and we're working together with Mozilla and Intel on SIMD.js, making sure that that path also works, which will be enabling us to run SIMD code in the browser. And our skinning code uses both so heavily that if you have thousands of characters around, the performance on that is actually a much bigger hit than that 1.5 times slower, because it's basically a feature we don't have, and we can't support this any other way. So when you think about deploying content, the performance mark of that is mostly in those types of subsystems. One thing that we showed during GDC, which is another demo which will come up later, is heavily using skinning. And they, at that point in time, in the nightly version of Firefox, kind of like the bleeding edge, the newest version of Firefox, had an optimization for floating point math. And that meant that we could actually do 32-bit math, and JavaScript numbers are always 64-bit, and it takes a lot longer to work on them. And with that optimization, we could already see like a speed increase of 20% over our demos. So from that point where that was there at GDC and a nightly, today the Firefox we're now running in has that. You know, they do these silent updates, people just get browsers, and these browsers get more capable, and we are allowed to target it as more and more people have those browsers, you know, with graceful fallback as it isn't there. SIMD has a similar pattern. You know, it's going to have a graceful fallback if it isn't there in the browser just yet, but if the browser supports it, you're going to get more performance. So your do's and don'ts there are that you don't always exactly know what kind of machine you're running on. And if you haven't deployed to the web before, and I hope you will consider after seeing this presentation, you know, if you do mobiles, you kind of know, okay, I'm targeting an iPhone 4 as the lowest thing, and I'm going to target the newest Android device as the highest end, or, you know, I'm going to target consoles. So you know a lot more about what hardware you're going to be running on. And if you do standalones, you know, you already have a further understanding of that. But here are the feature range that might be or might not be available that will impact your performance of your game is currently a lot higher. You know, you might have somebody who has a Firefox browser running content great with SIMD.js in the future. And there might be somebody else with another browser that doesn't have that. So that this is also where we want to be part of that effort, and this is what we're doing together with Mozilla and Intel to make sure that that is a standard, that like everybody can adopt that, and make sure that it's something where we can run really fast. So this is an ongoing effort for all of us. It is still early days, so those kind of features that are now coming in, you know, we have to figure out when we can enable that and put that on, and when you hit build, that happens. We're going to quickly iterate on WebGL as a whole, and on that quickly iteration, you know, it's early access, so we're trying to figure out how to do this right. We're trying to figure out how we can target as many browsers as possible while also giving the best deployment options. So there you have to think about limitations that go beyond that. Without WebGL 2, you're locked to WebGL, and WebGL 2 is still not there. It's underway, it will come, and it will allow us to do a lot more, but today you're locked to WebGL, which is kind of similar to OpenGL ES2. So basically mobile devices map very well, the less modern ones that don't have OpenGL ES3. You know, that maps very well. So a lot of times you will not hit this constraint if your game is a mobile game already. If you're like using our DirectX stuff, that will not run on the web today. Our DirectX 11 compute stuff, for example, that's not something that maps to the web today. Then you have to think about the supported browsers, and you have to think about download times. And this sounds a bit scary, but with that plugin model of our web player, when the user has that, when that 93% users of our users have that plugin, it means that they already have the entire engine on the machine, and then the next game that they hit, you know, they don't have this problem. They can just run with the web player now installed on their machine. We can't install anything from the browser. We are shipping one game, which will be converted entirely to JavaScript, and we will ship that to that user. You can't do it any other way today. Now, for us, what we've done is enable a whole lot of work that we've been doing over Hack Weeks, which is another part which is called modularization, where we pull pieces of Unity in such a way that we can enable and disable them. So for WebGL, that means that if you're making a 2D game, and you're not using any physics, and you're not using any Umbra, we automatically pull those systems out of the engine as we are compiling your content. If your scripts don't use half of the APIs that Unity exposes, we pull those away. They're not going to be there. We're going to rely on our stripping, the stripping in IL2CPP, and the stripping in LLVM, Clang, and make sure that everything disappears. So we're going to show you a couple of examples, and I'll kind of let you know how that is, but we can see that we are already having content that is smaller than the install of the web player plus the content in WebGL that deploys. So we're actually smaller in many cases while we're shipping the entire engine and all the content. And this is one of those things where we kind of started enabling work that a lot of people already worked on, took it, and I'm going to now stop bothering you with too much talk and ask John to play a little bit more. Oh, I forgot one bit, sorry. Scripting support, this is another kind of consideration. So basically you can do most of it, most of the stuff on the asset store work. Today we have Playmaker working in WebGL, so you can take that. We have UGUI, you know, all managed code, all C# when we open source it working. Reflection works, generics works, link works, XML works, so all these kinds of language features that you're used to using, they work. There is always going to be something. This is an iteration for us. Most importantly, IL2CPP is an ahead of time compiler, and that is similar to what you have if you're deploying to iOS today. Those restrictions apply. You can't use Unity script eval. like to generate new code, which kind of comes back to we cannot emit code at runtime because we're doing this all ahead of time. Now, again, for that, I'm going to point you towards John. I'm not going to go too deep on this. There will be bugs. We're going to rapidly release new versions. We're going to be in that kind of rapid weekly update cycle to fix stuff that we didn't intend to be broken. Today, no threads, no sockets. We'll get there. The one thing that is important to note is that there's no sockets and no threads in your scripting code either. We cannot support that without those features being there entirely. We cannot map system.NET sockets to WebSockets or WebRTC, which are two of those HTML5 standards that there are. So we can't support that, but there is a way to do it yourself. And now I'm going to ask John to play a game. And I'll talk a little bit over that. Oh, no, we'll play the game now. So I hope it works now. Again, you have to close the other one. This is what we announced at GDC, which is a Mad Fingers game called Dead Trigger 2. I hope you've seen it on mobile before. Maybe you've seen it online. Has anyone already seen this? So again, this is a mobile game that we took to the web. This is all WebGL, and here kind of that point of skinning comes in. The intro of this game contains a lot of highly detailed animated characters. And in the web player, in the WebGL export, we don't have threads, we don't have SymD, so this is slightly slower. However, as you can see, and it's kind of visible in the top left corner. I'm not sure if you guys can see that number there.
Cover me.
Can you see like the second number in purple? That's the frame rate. So that's 38 right now, and that actually comes from a starting point where we were running 2 frames per second. And again, this is during a part where skinning is very heavy. As we kind of move in other scenes and these characters disappear and there is no more animation going on in the end engine, it goes away. But we've seen this being highly playable even on low-end machines. Right now, this is the settings are all cranked up to high quality. Here we go. So you've already seen this, and I kind of want to show you some of my personal high points in games of Unity that I could get my hands on. Well, let's just continue. This one, Ski Safari. Actually, during that first hack week that we did, doing the first tries, the other thing we were doing was all playing Ski Safari. They kindly permitted me to show this to you, and this is a very kind of, casual game. It was really, really popular, or it is really, really popular. And this is, out of the box, this works. There's really nothing done on the project, it just works. So we compile this and everything works. And again, when we talk about that stripping, this game doesn't use Umbra occlusion culling. So it's not there. The deployment size of this is a little bit bigger because of the amount of textures that are in here. There's like high quality textures that are uncompressed. We compress a lot of the content for you. In fact, one of the later additions that we recently did is that web browsers can take gzip data. And while you can configure your web server to do so, and most web servers already are, what happens then is that if you put a JavaScript server file on your server, which is big, and you say gzip this content, every single time it will compress that data and push it out there. So actually the bottleneck for performance becomes the server, because if your game gets popular, it's compressing all this content all the time, and it does it over and over and again. And there must be a way to configure it, but what we did is actually compress them ourselves, put them in a JGC format, put them on the server, and now the server can basically serve up that file directly, give it to the web browser, it will unpack it, so you get this really tiny compressed thing. The other thing we're still working on is compressed textures. That will not be in 5.0. That is not normal compressed textures like formats for the graphics card, but it is crunch compression. We decided to wait a little bit with that until we know for sure that the rest works well, but that will even further decrease download sizes for games. So we took that very serious while doing this. Now, another really nice thing, I kind of work a whole lot, and as I said, I don't get to do a lot of gaming, but this came by on my Twitter feed and I was hooked. I'm not sure, George, are you here? George Ng, he made this game, and I started playing it. I must say it's not perfect just yet because I made a mistake while deploying this one, and I don't have the newer one, but, oh, does it? It's actually, oh, you can't full screen this one. Sorry, that was one of my. So I saw this coming by on Twitter, and it's a web player game, and I started playing it, and I basically wasted 3 hours of my day, and they're kind of valuable. So I had some catching up to do in the night. But I finished the game, and it's actually an ideal game in terms of an example of something that runs in the web player today, which really doesn't use any features that we can take to WebGL without any problem and make it much more accessible. now that link in Twitter doesn't become like you don't have the Unity web player if you don't have it. No, it just becomes a game you can play. So that engagement, that direct, from link to playing is almost nothing. And I mean, this game really, I love it. The narrative, the music. I highly advise you to play the web player version. Maybe me and George can work something out of getting this online when we're done. But come and I'll buy you a beer because those were 3 great hours. So this is a really great example of something, something you can take today and take over. This is actually the entire game, plus our Unity engine, plus all the scripts, which is like a big part of all .NET, plus Unity script, plus a couple of packages from the asset store. That entire thing was about 11 megabytes total. So that's all the graphics, that's the entire engine, that's everything. And if you look at our plugin download, you can kind of see how our stripping and our kind of compression works here. Now this demo you saw today. And this is Prime World Defenders. It's by Naval. They kindly allowed us to use this for the keynote this morning. I don't know what's going on. Let's go. Yeah. So here's a much more deep, much more long play time, deep interaction. Let's wait here a little bit. Oh, okay, that's fine. Go and play. Now you have to show us how good you can do this. Better than Lucas. That's a good point. So. This is kind of like the tutorial level for a game, but this is now, today, like an iOS game that is shipping. It's very popular. It's targeting higher-end devices on mobile. And we have to admit, we did have to take a little bit more time because this game was basically using every language construct and every piece of code that you could imagine. And we kind of found some bugs that we had. We had to do a lot of work to get this going or after finding it, but this is exactly what we want to do as we're iterating over WebGL. Take the hard stuff that we haven't hit yet, make sure it works rock solid. The game, again, look in the upper left corner. I don't know, can anyone call the number out? It's just 60 frames per second. And again, it is a lot of skinning. There is a lot of going on here. There's actually a giant amount of script code that involves this. One of the things that we couldn't support today is, for example, the Facebook SDKs that the game is normally using. That's something we're working on. And to kind of allude to what I said before about sockets not working in .NET, that doesn't mean that you're actually excluded from using them. It just means that we cannot map .NET sockets, but you can still, using WebGL plugins, and this is a strange concept, write it yourself. And normally in Unity, a native plugin means that you use some native functionality from scripting land. Somebody has written that for you, you write it yourself. For example, Vuforia, Qualcomm's plugin, does AR, and all the processing is done there. In this case, what you can do is drop in C++ files in your native plugins folder, so you can write C++ or JavaScript, and then give it script bindings so that you from C# can communicate with JavaScript or C++ directly, and basically write your own sockets as they map to WebSockets or WebRTC. In the case of sockets, it may be a little bit of a moot example because we're going to place something on the asset store that does that. We don't want to officially support that. We're just going to put it out there for people who need it. Because later in the 5 cycle with UNet, which, has anyone heard about UNet? Our new networking for Unity. So native networking to Unity, we're going to be actually supporting WebGL with that too. And this is something, I'm not going to make promises on release dates, but it is actually something we're already working on, making sure it works. And I think I'm closing in on a mark where we're almost done with these demos, I guess. Yes. Which leads me to the final point. We want your content. So today you can't yet. We're going to get to a point where this is accessible to you. And it's very important that I reiterate, this is going to be free. This is going to be free for free Unity and for Pro Unity. This is going to be something that you can use to deploy content to the web. And one of the kind of things I want to propose to you from a use case standpoint, like we've been looking at all kinds of games, but what Unity really is as a platform, it can do a lot more. You can, if you want to have a car spinning in 3D on a website, then Unity is going to be the best tool set to do that. If you want to do other things with Unity outside of gaming, and you want to bring it to the web, then this is kind of like that frictionless step that you need. Like if you look at the Tron movie when it came out, it was actually using the Unity web player, which is really cool, but it did have a threshold for people to see it. And this is again that question about if people don't have a plugin, then there has to be enough incentive behind downloading the plugin and installing it for them to see it, but that's gone now. So you can start using Unity for a whole lot more online deployments. And with posing that, I first want to thank Mozilla one time more. I want to thank the entire WebGL and ILTCPP team, and some of the people involved here, are on this list. These are all our Twitter names. Make sure you go to John. His talk is great. It really explains what ILTCPP is. It really shows off. One of the things I just forgot to mention is that if we run in WebGL, your scripting, we run scripting code that is heavy, like the Mandelbrot this morning. If you saw it like a fractal, that is very scripting heavy. We're actually faster in this version of Firefox today than we are in our standalone player with Mono. So we're actually faster than native in JavaScript, which is kind of welcome to 2014, I guess. How many minutes do we have left? Because I would like to... Okay, so the last thing I want to say, if we don't get to all the questions, come and visit us. We're at the hands-on lab. We're at the scripting team table. We can talk about ILTCPP, WebGL, all of your scripting. Martin is going to be around here from Mozilla. I know that they are eager to help people getting the content online, getting to work together with you too. And am I saying that right, Martin? I guess. Yes, so Martin will be around too. Make sure you meet up with us. We'd love to talk. If you have deeper questions about any of this, meet us up. And now I'm going to take some questions. Go ahead.
Downloading the same game over and over may be a concern for some users. Will you guys support something like IndexedDB?
Yes, we already do. Things like player prefs, which also need that, but even a file system, we pack things up. So if you have your resources folder, or even things that you would normally have on a file system, we can pack themselves up in the game. They go into IndexedDB. And that's being used. Player prefs being stored there. Cookies are a bit small for that kind of stuff. So we use IndexedDB. And this is, again, the HTML5 stack we're using. And I'm saying WebGL all the time, so well, maybe put the thing a little bit short. Go ahead.
Are you guys coordinating with Google at all? Do you know that the web player is going to stop working in Chrome this year?
No, we don't. We are not, well, I mean, we're not doing that, and we just don't know when they're doing that. They've made announcements about this. They're specifically disabling MP API. That's not just us. That's everything that's MP API. And I think that given the current state, it's a bit early, but yeah.
I couldn't agree more. A lot of us have our web games up, and so
yeah.
balancing when do we push them to GL and when are they just going to...
Yeah, I mean, I can't really say, I can't speak for a third party, and I hope that that's simple enough as that. But I mean, do contact with them with this message. For the rest, we're going to try and get you up and running on WebGL as quickly as possible, hoping that that's possible. It is important to note that we do also work with Google on our WebGL exports, so it's not all bad. Go ahead.
The current version of the web player, you can do things like call JavaScript from inside Unity.
Yes, that's still working. Yeah, I mean, the calls to just, so there's multiple ways. You can just call JavaScript like you do today from the web player, that works. But that more luxurious way, you could actually take something like FFmpeg or something that imports EXIF pictures and drop it in that folder and communicate with that too. So it's kind of double. But the simple way of just making a call or getting like an alert dialog just works too. Okay. I think you were first, but I'm not sure. I'm missing probably people in the back.
Does it work on Chromebooks?
I haven't specifically tried, but I know that with Angry Bots we did try it. This is a while back, and then it was running, but not great. I heard later that it was better, but I'm not going to speak of that without actually having those numbers. Go ahead.
There are a lot of corporate users still using IE. Do you know what's going on there with WebGL?
So we're working with every browser vendor out there to make this a reality. Today, I can only say that with the current tech stack available to us, we can do Chrome and Firefox and Safari when the new version is there. On IE, I can't speak. We'll be working with them to get this to work. We want this to work everywhere, of course. So where we can help, we will. But in the end, it's about HTML5 and WebGL compliance that will make this happen. And we also really hope that browsers take the asm.js route. So we're going to always put that on the table when people ask us for support. Go ahead.
Is WebVR on your radar?
Sorry?
WebVR?
Kinda, but we haven't really delved into that. We're really making sure that all of this is rock solid. So we really want to focus on just getting that experience perfect, for you as a developer, but also for the end user and accessing that game. So that is further out for us, but where we can and we have the resources, of course, we want to see what we can do there. Wow. So I'm going to say this one more time. We have a WebGL table at the hands-on table. I'm going to try, until I get cut off, I'm going to answer questions. So there you go.
Free versus Pro, is there going to be any feature difference between those on WebGL?
Yes, normal feature split. So you want render textures, you don't have them in free. That being said, the deployment itself is free like the web player is today. So basically it's the same deal as the web player already was. Go ahead.
So you mentioned that WebGL can't access the file system, which is pretty expected, right? What if the user specifically, can the user specifically acknowledge access and then allow us to save a file?
I don't know well enough. I know in the past I did something like that when I was still doing stuff on the web, but I wouldn't want to answer that without looking it up or consulting with somebody else. Maybe Martin knows.
So you can do IndexedDB for permanent storage, and there is a file API being worked on that would allow like a sandbox file storage, but it hasn't been finalized yet.
Okay. So I'm going to take the last one because I'm seeing this being done to me. Well done. Go ahead.
So www and asset bundles, do you support both of those?
Yes, they work today. We also support www audio clips since about 2 weeks. Audio is a special one. Audio kind of, web audio is kind of hard because there's a whole bunch of standards. And this is one of the reasons we were also kind of like, it's hard to expand to browsers because if they don't support like MP3 or something else, it's like AAC, MP3, all these different formats. And this kind of standardization of the API is there, but now the formats beneath it are. And this is similar to what we have with mobiles, for example. If you would want to run on mobile, if we ship compressed textures for a desktop machine, they're DXT compressed, while mobile phones will want to have EDTC and PVRTC. And this is basically why we're focusing on this part and making sure that all the Unity APIs works like www and asset bundles, and then kind of expand to further. So thank you all for your time. Come visit us. And make sure you go to John's talk because RLTCPP is mind-blowing.